I have a lot of certification, primarily coming from networking and secure application development, and also offensive part. Of course, I have a hacking forensic investigation incident responding. This is my shorter email address, jandan@normshell.com. Sorry, and this is my Twitter handler. Okay, let's go. So today we'll cover basic analysis, basic static analysis, and also basic uh, automated analysis, and also basic dynamic analysis. So these three things that we are going to cover today. I'm going to share the slides with you guys so you can download the tools if you want. And not all of them have to be in your system, but you may at least be aware of there are some products that help you to do some analysis on that. So primarily, when we started to analyze a malware, we don't usually submit it to VirusTotal directly. It's you know people usually think that if we submit a malware to VirusTotal, it's a good idea for incident response. It depends actually. If it is something that you think that the malware submitting the VirusTotal is not a big problem, that you can submit it. But if you are faced with an APT, and if you submit your malware to VirusTotal, you are letting your attacker that you already catch his malware, okay? So it depends. Sometimes you may start from automated analysis or maybe start with the basic analysis, okay? So that's why I usually prefer basic analysis first. If I wanted to submit something, I submit the hash first, and then if I figure out that the malware exists before, then I may consider to submit the whole malware. So just keep in mind that starting point is usually the basic analysis. Unlike, it's not the automatic analysis. Okay, so in basic analysis, what kind of things that we need to take a look at that? So first of all, in order to analyze a piece of artifact or piece of potential malware, we need to know that it is really malware or not. Okay, and also we need to identify what kind of malware, what kind of programming language it contains, and then we can use some of these tools to analyze and figure it out what is going to do this piece of malware. Okay, so we are gonna take a look at for example, some C# tools which will help us to reverse engineering on that tools, and also we will take a look at some Android malware, and we will use jd-gui with dex2jar, of course. And also we will take a look at the dependency walker in order to figure out whether there is any executable file, but what kind of executable we need to identify, whether it's a C, C++ family executable, or it's a C#. If it is C#, it helped a lot. Okay, so how many people know that C# codes are actually can be easily returned to the source code? Interesting. You didn't know that? If a code is written, if a malware is written in C#, we can go back to the source code easily. Okay, I'm gonna show that. You're gonna love that. That's a big plus. But if it's written in C, C++, it's not that easy. Actually, it's almost impossible. Okay, and then we will use some tools to analyze the basic parts, and then we will go to the automated analysis. And at this point, we think that, hey, I think we're in a position that we need to run this malware in an environment that we can get some extra help from other tools. First of all, VirusTotal, malware analysis, and there is another one, hybrid analysis, threat expert, of course, Kuka sandbox, and you can use your own Kuka sandbox, of course. So things like that. And then after we get enough results with static and automatic analysis, we will consider to do some dynamic analysis as well. In the dynamic analysis, we are going to run the malware in a sandbox, in a controlled environment, and we will figure it out what this malware is trying to do. Okay, what kind of DNS queries, what kind of IP connections, what kind of activities happening on the file system. Is it trying to lock something? Is it trying to write something? So those kind of things, the behavior of the malware, we need to identify. And so in this dynamic analysis section, we're not going to just double click on a malware and just run it. Of course, we would like to keep the malware as protected as possible first. So for example, we will lock the DNS queries with appended DNS, and also we will simulate some internet like Ramnax inet sim, And then we will understand that, hey, this malware is trying to connect with that server with the IP addresses and trying to get this thing. So you can, create a copy of that thing to your simulated internet environment and then trick the malware to do something. Okay? And then we will, of course, use some of the system internal tools to analyze what's happening on the file system in terms of which processes are running and what kind of registries are running, what kind of files created or deleted, things like that. Of course, process hacker, or if you're a process explorer fan, that's also fine. We will take a look at the process hacker to analyze the malware and what kind of communications it is trying to do. And by the way, you may need the everything search because it's everything search actually indexing the all files names on an operating system. It's easy, small tool, indexing the all file names and putting in a searchable list, so you can quickly search for a file name. Okay, because in this environment you may need to find a file somewhere, and this really helps you to find that very quick. Okay, because Windows search, you know that it's not index search, right? If you use Windows, it's trying to look at every single files one by one, but instead this thing is just searching for the list of the file names already compiled. And Wireshark, we already covered that before, and we will take a look at the traffic of that piece of malware. And at the end of this dynamic analysis, I'm going to show you, it's not a malware, but malware developers use a lot of techniques that exist on that executable. So these techniques are known by the malware creators as well. So they know that they're going to use this. So they know that you're going to use these tools to analyze their malwares. Okay. So that's why they are using some let's say anti-malware analysis techniques. Okay. So those kind of techniques can be, force you to do some advanced static analysis by using the IDA and also only debugger, unless you're not running, of course. And also, this is actually two of them are identical. And then we will do some advanced dynamic analysis with the same tools, but this time we're going to run the malware. Okay, with that again in a sandbox environment, we will know that the malware is trying to do something in our system, and there is a really important rule that you have to have a snapshot on that virtual machine, because you will eventually infect your machine while you are doing that dynamic analysis. Okay, because it's the malware, if it is do the thing that it is planning to do, then you're going to run. It's going to infect your machine. It doesn't matter whether you are doing for training purposes or not. If it's a ransomware, it's going to lock your files. Okay, so that's an important rule. And in this case, we are going to take a look at some of the anti-analysis techniques, which means malware creators know that our analysis techniques, and they create some anti-analysis techniques. And we are going to use some of the anti-analysis techniques to analyze their advanced techniques. So that's the theory now. But let's start with the basic static analysis. So the basic analysis are going to be this meetup, and the advanced analysis are going to be in the next meetup. Okay. So I wanted to start with a couple of P analysis. So I have two editions in my environment. So one is this Windows box. The Windows box is actually includes a lot of static analysis tools, and actually I shared the pretty much of them with you guys. But if you wanted to ask for the what is this and what is it, I'm going to explain that during the meeting. Okay, actually meetup. And another one is actually a small test environment. So this is the environment that I never run a malware, just for static analysis, nothing else. Okay, but I have a separate edition, which is this one, Windows 7 malware test. In this environment, I'm running the malwares actually and trying to figure out what is this thing is trying to do. Okay, so let me run this, and let me say don't upgrade. And as you can see, guys, here I have a virtual machine, and that has to be snap. Well, okay. Virtual machine and snapshots. Let's say snapshots here. So I have a snapshot here. I can easily turn back to this point. So let's say restore snapshot. This is the thing that we have to do multiple times during the malware analysis. Okay. All right.
My
So.
understanding on networking is blocked, so it cannot go on.
Yes, yes, exactly. By the way, if you are dealing with a malware, it has a potentially, um, it has a potential to escape from sandbox environment. Let's say somebody found a zero-day exploit on VMware Fusion that allows a malware to escape from virtual machine to host machine. That might be the worst scenario that happened to you, but I don't know. That never happened to me yet. But huh? Yeah, that's actually another question. I don't know. So let me quickly fix something here. Display. Okay, yeah, there we go. Okay, yeah, fixed. All right, so let's start with some of the malwares that we can do for the static analysis. So let's start with the funny things. Okay, so let's start with this one. Okay, let me copy this and put it in my malware static analysis machine, and let me create a temporary folder here. I already have one, but let me create a malware directory here. Okay, the first thing we need to do is what kind of malware is this? Okay, so here's the problem. If you see an extension that says .exe, it doesn't mean that it's an executable. Okay, there might be multiple reasons. First of all, in Windows, by default, the extension is hidden. Okay, remember that. If you're using Windows, you need to disable the hiding the extension. Okay, and it is under this menu. What is it? Let me see. Tools, folder options, weave, and yeah. What is it? Yes, hide extension of known file type. So it is known by you, but it's not known by me. So if I see something like this, it doesn't mean anything for me. Even if I see it, it still doesn't mean anything, but at least we have an idea that it has an executable, and the default handler for executable is the Explorer. Okay, so uh, when you click on that, the Explorer is going to run this executable. Okay, so we know that, but we need to prove that this is really executable. How do I know that? In Linux environment, if you're using Remnux or Kali Linux or any other, so you can use file command, okay? File and just give the file name, okay? When I say that, it says it's a P32 executable, and it's also giving me a lot of information and saying that it is mono slash .NET assembly, which means it's a .NET code, .NET executable, which is brilliant, you know. Luckily, there are a lot of malware developers. They don't know how to write in C++. That's a big plus for us. They are using C# and they don't know of code obfuscation. That's good thing for us. So if we are in that position, we have a big plus. So let's understand this without even running that. Okay. So what I'm gonna do is first I'm gonna put it in my CFF Explorer. So try to figure it out what kind of sections it has. It will give me a lot of idea as well. So CFF Explorer, I already mentioned that in my slides, and also I shared the link, so you guys download that from that URL. So if I move that, again, I see a lot of information here, and also it is saying that this is Windows 32, Windows Visual Studio .NET Assembly, which is perfect. And as you can see, guys, its version number is not legitimate. So if you see something like this, it means it's developed at home. Okay, this is something that you can't see in a real Windows applications, right? So it is obviously a non-professional. Okay, so this is something, and also you see that it is modified at October 2015, so which is another idea that gives us. And of course, you can take a look at the headers, but I'm not gonna dig into the details of these headers. But some of the important ones that I wanted to show you guys: .NET directory. Okay, this directory gives you a lot of information, and let me show you the tables. Okay, let me actually show this tables. Okay, so here it says methods, and also there are a lot of methods here. There are a lot of parameters here. So, and also memory references, although they are a little bit complicated, but I still can understand it, right? So some select character, next, CTOR. So these are the function names, but it's a little bit obfuscated. It's not a professional obfuscation, but at least it's that there is an obfuscation in here. So there's something going on here. So first of all, we have an idea. In a normal .NET application, you don't see something like that function named like this. So let's find a legitimate .NET applications first, and let me see where we can find it. Actually, let me show you the everything. So Fiddler, okay, Fiddler is right here.
You mean function which doesn't have meaningful name? Would it be like without a foreign language?
Yeah, maybe foreign language as well, but I believe that if they are using a kind of, you know, garbage letters, it's trying to trick the analyzer. So I usually don't trust them. So for example, this is Fiddler assembly code. I mean the methods. As you can see, it's add imports sessions, add reported session, trim session list. So I see a really human readable function names in Fiddler. By the way, Fiddler is written in .NET. I know that before. That's why I quickly jumped that. But I can easily take a look at here. How many people used the Fiddler before? Great. Fiddler is a really good proxy, web proxy, local proxy running on Windows environment. So you guys can use that. And it's also written in .NET. And again, I see good function names here. But my executable somehow have an interesting function name. So this kind of function name, it doesn't mean anything for me. So that is something that I need to worry about. So how can I get the source code of this thing? Because it doesn't mean anything, right? So this is the tool that you can use for that. I also mentioned that in my presentation as well. ILSpy. Actually, how many people heard Redgate Reflector before? Redgate Reflector? This is it was actually the very first version, and ILSpy is also another version of that. So let me get rid of this and get rid of this as well. No, I don't want to download it right now. So this helps you to reverse engineer the .NET applications to its source code. So here's the magic is coming. If I drag and drop my executable file here, see that even the commands here, temp malware, C#, metapreter, natural something, and using something. So here is the MS corelib and the corelib functions as well. So this is a function, should be a class or function, but it has a dash name. And also this is the main function that the application, when it's run, it is running this program, and then it runs this one. So this is the source code of this piece of executable, which is fabulous, right? When I see it the first time, I really surprised out. So let's analyze this. This is a C# code, obviously, and we see the functions here: private static bool and interesting file, function name. Again, interesting function name here. So those function names are also used by as a overloaded method here. As you can see, this class as a function name, which takes a parameter this one and this one. So this is not a legitimate application. So let's compare it with Fiddler as well. Again, let me drag and drop here the Fiddler. So as you can see, guys, Fiddler, autoresponder, autoconfig, and where's the main function, by the way? Fiddler script, Fiddler expansion, executor handle. Anyways, let me click on any of these things. Okay, you can see that Fiddler application write, says, event arguments, and get and set functions. It's really readable and it's nice looking, right? Human readable, and also you can see the commands of these executable, which is perfect. And also, if you wanted to develop this code by yourself, if you wanted to have the executable code, you can of course copy and paste to a file to create the source file, but ILSpy has a fabulous feature. If you click on the executable and then file and then save code, it's going to create your C# project. That is fantastic. I really like that feature. So you can get the C sharp code as a project, and you begin to develop that, and you begin to modify that code and compile it. That's that easy. So let's come back. And as you can see, normal executable, they usually don't hide their function name. Hiding function name is something unusual. I'm not saying that it means that it's malware, but it's unusual. Okay, and malwares are usually unusual.
If you strip the symbols, will you be able to find function?
Sorry.
If you strip symbols.
Yeah, I mean, you can come up with some meaningful names and try to figure out what this function name is kind of look like. So, for example, obviously this is taking a string and returning a char array of this thing with sum in with the 256. I think it's a kind of a shifting of a string, and it's checking for a 92 equivalent. So it's a kind of encoding. Obviously, this is also another way to obfuscate the code. So probably there are something here, and they are not human readable. And he doesn't want to easily code by the source code analysis. He just wanted to hide this thing, and this thing probably be decoded with this piece of code segment, and then it will be the function name that we are looking for. So as you can see, guys, there is a certificate here, certificate chain here, SSL policy here, which means either there is a SSL communication or there is a public key infrastructure is going to be implemented. So that is another thing that we understand here. Let's scroll down here and let's see what else we have here. And as you can see, guys, it says web client. It's a .NET class library. It's a web client. It's going to create a web application or at least a web request with these headers, user agent, Mozilla, something, accept any language and any kind of things, and download some data, and the length is similar, small than this one, it's going to do the rest, okay? So that is interesting. Obviously, it's going to download something from somewhere. We don't know, but we know that it's going to download from somewhere. And here's the thing. Finally, we see something main function. Main function has to be named with main. No way. It cannot be renamed. So if we change the main function to, let's say, another garbage thing here, it's not going to work. Because whenever an application runs, it runs the main function first. And it has to have a main name. That's why the main is obviously a main. And I see some of the dates, random text here. It's getting some random. And here is https://local.443 and getting some URL. So obviously this is going to connect to my local machine, which is local, and port 443. It's going to be HTTPS connection, and it's going to get some URL in order to download something, and it's going to be run in the memory. So as you can see, guys, if it is a C# code, super easy. It will help you a lot. You can easily understand. Of course, you can analyze this encoding thing and reverse that encoding thing, and you can open that URL segments as well, so you can easily understand. So this is one thing that you can do in a static analysis. Okay, and let's find another malware which is not C# code. Okay, so in this case, this is going to be our thing. We wanted to analyze this. Let's copy this. And actually, before that, let me copy this thing first. By the way, if you're working with real malwares, it's a good idea to change the extension to something that is not executable. Okay, so for example, I usually put the hash at the end of the file so I can understand that this is something with this hash. Whenever it changes something, whenever it is modified, I can easily understand that it's not matching with its name, so it is something modified. Okay, so this is something I already said, it's a packed word. How can I know that it's packed, and how can I know that it's an executable? Again, let's use the same technique. Let's move, drag and drop this to my command line and figure it out whether this is an executable or not. Obviously, it's an executable. It doesn't matter if you change the extension. As you can see, the extension is something really doesn't mean anything, but it's still obvious that this is an executable. The file type is defined by the very first 4 bytes of a file. Okay, it is not defined by the extension. Extension is actually related with the operating system, but the first 4 byte is related with the file itself. So you can change the extension of a file, but the file itself doesn't change. You're changing something on your operating system, okay? So that piece of the byte array, let's say this is something, a lot of bytes, right? This thing is not changing whenever you change the file name, okay? Because file name belongs to operating system, permissions belong to operating system, but bytes belong to the file itself, okay? So that is why even if you change the file name, it's not going to change anything. So, and this file command is actually checking the very first 4 byte of this executable, and then telling you that, hey guys, this is something executable. Okay, so obviously it's executable, and let's analyze with our CFF Explorer again. So let's get rid of this because we already take a look at that. And I'm gonna move this here. Okay, so this time when I look at it, it says portable executable, but file info is UPX version 3.0. That's interesting. What does it mean? So let's find some regular application. Whenever you confuse something, just find the regular application and just compare it, okay? So it gives you a lot of ideas while you're starting to learn something. So I usually, use the system internals to compare the things. Let's say Control N and computer system internal. What is it? Okay, yeah. Let's use one of these, and let's use Utrans. Okay. When I click on that, it says Microsoft Visual C++ portable executable, but it's something meaningful. So we usually expect in the file info section what kind of programming language is being used. Remember, in the C# code, we see something Visual Studio .NET executable, right? But this time, in this file, we're looking at something UPX version 3.0. How many people know UPX? What does UPX mean? Okay, UPX is actually Universal Packager, which means it's packed, okay? What is the difference between packed and unpacked files? So malware analysts, malware creators, they already know what you're gonna do, okay? They know that you're gonna use some of the static analysis techniques. They know that you're gonna use some of the string analysis, things like that. So that is why they are hiding their real intent unless you run that executable, okay? So, for example, let me show you something in a bin text. What is it? So, bin text, there we go. So bin text is actually a small executable which helps you to find all the strings in an executable file, okay? And I'm gonna use my executable to analyze its string, okay? And before doing that, actually, let me use a regular normal executable. So for example, bin text itself have these strings, okay? See that? The file is Windows 32 PE file. The decimal string is resource, Microsoft Sans Serif. So some of them are really human readable text, right? So you can easily understand the save text file, txt file, command line, things like that. So this is a normal executable file look like. Okay, we usually see something in an executable. If it is not obfuscated, if it's not packed, we see something like this. Let me drag and drop my potentially malware file, okay? So if I drag and drop this, you see these strings? Make any sense? No. And this is something, if you see something, there is a 90% chance that this is something malware, okay? You can easily identify that you are really facing with an, let's say, packed malware. So this is a really good example of packed malware, and this is a really good example of finding a kind of a malware. So for example, let's take a look at our C# example here. And so here, for example, if I scroll down here, I see the do txt, remember, and also I see the command and control center, right? So it's been coded in the static analysis. So the malware author of this malware just screwed up, right? Because You just couldn't pass the first level. First level of analysis, they just code. It's not good. So even the static antiviruses can catch this malware. So it's not good. That's why they are packing theirs executable. What does pack mean? Let me quickly show you an example. So in normal executable, here's the code section. Let's say here's the txt section, and also rest of the file. Okay. So this part, if it is open, it's not packed, you can easily read that. And the malware author is obfuscating this, let's say a kind of encryption here, okay? And this decryption code is embedded in the code section, okay? So in the very first segment of the executable, there is a piece of code that decrypts the rest of the file and use it for the purpose. That's why we can't see the rest, because when you run this file, it is going to be decrypted, it is going to be plain text format, and then you can catch it. But unfortunately, at this stage in the static analysis, you can't see. Is there any chance that we can decode this? Since this is a UPX is a very well-known packager, and there is a depackagers available, and CFF can do that. Let's do that. And CFF, let's go back and let's, it's a UPX file, and here we have a UPX utility, and I'm gonna hit unpack here. It just say it is unpacked UPX something TMP, and it's embedded, and it's created another version of this pack file. So what I'm gonna do is it creating the file directly, or I need to save it. Okay, let's. Okay, I think files save as, let's say, unpack. So we save that file, I think. Let me drag and drop this file to here, and let's see. Okay, so in this case, we're looking exactly the same file, but this time it is unpacked, and we see that it's Microsoft Visual C++. And let's analyze that in our bin text, okay? Because a few seconds ago we see that there was a lot of garbage text, but this time when I drag and drop, I see again a little bit garbage, but I will see something meaningful if I scroll down a little bit more. There we go. Okay, so Spanish, China, South Korea. Obviously, there are name of months that we didn't see before, and also country names, some language things, and also some description here, deleting new, and creating something, downloading, and index HTML. It's gonna do something, download something, and it's going to be an HTML thing. And we see some HTML here. See that? It's a piece of code, and there we go. It's being code. Download.megaget.com. So this is actually a piece of malware that whenever you install that, it changes your default search engine, and also your home page, and also download some adware, things like that. This is one of them. Okay, I hate these. They don't do anything other than annoying you, and it's not a serious malware as well. So I don't like this kind of stuff. Okay, so it's installing some adwares and things like that. We can check out for they are also trying to increase the hit of their YouTube channel page and things like that. There are a lot actually. We can, of course, get a lot of information when we see the string text. So it's obviously going to do some adware related things, and it's going to download something from media.com site. And this is how you can get around and packed malware. Okay, this is the second stage that you can actively use bin text and CFF, and also unpacking, UPX unpacking. Okay, is that clear? Is that clear how we can identify a pack file and also unpack that? So there is a question, maybe actually a lot of people are asking that, what if this packing thing, okay, this is, okay, same file, I think. Let's assume that this file was packed with some of the packager that we have never heard before. Let's say we see something, it says UPX, but it's not actually UPX, it's something else. It's totally different thing. How can we do that? That's where the dynamic analysis lens dynamic analysis comes out. So we know that in order to run this executable, it has to decrypt the rest of the file, right? It's not useful if it doesn't decrypt that, right? It has to decrypt in somewhere, and we can attach a debugger to this executable, run step by step. Whenever this piece is decrypted, we can pause this execution flow and then copy that content, put it in the file, and put the headers, and we can compile exactly the same executable, which is unpacked. Whether it's a custom packager or not, it doesn't matter. We still unpack that. But this is the easier way to find an. And a lot of the malware developers, actually 75% of them are using UPX because they don't know to write a custom packager. Okay, so this is the good thing. Let me give you a secret. Malware developers are not that professional as well. So there are some professionals, but majority of them are mid-level.
That file info, is that just some text embedded in the header of the file or something, or is that tool examining the content of the file?
Actually, it's a text embedded, and also this tool is analyzing whether it's consistent with that thing. If it's not consistent with that algorithm, it just says that it's a custom UPX, but it's still relying on that text. But this doesn't give us anything, and unless this doesn't work, it doesn't mean anything. So it may, I can write my name over there. So, but it can give you an idea at least. Okay, so that is another thing. Let me see what else we gotta cover. Okay, so by the way, there is a strings executable available on the command line. You can use that, and it's in Linux and also macOS. It has a strings on, but usually we deal with malware analysis on a Windows environment. You may want to use Bintex as well. So it's not listed here, I think, but I'm gonna put that. Promise. Okay, let's take a look at some Android files. And by the way, what time is it? Okay, what is besides people?
Patrick is out there.
Patrick's out there. How about pizza?
They set up the table, so I think it's inbound.
Okay, okay. All right, great. So I have an APK file. It's a battery APK, and I see a lot of applications on the private market that say download the APK file of this thing, which is a cracked version, which is a Candy Crush cracked version, or let's say ad-free version of this particular applications. There are a lot of markets actually. Let me show you something. It's a again, what do you call shameless advertisement? Where is my browser? Okay. Let's see. No, not private domains. It has to be plugin applications. Okay, here. For example, here it says Acme free Android app games download somewhere, and it says free download. It's the exactly this is a legitimate application you can find in a lot of wares. Of course we hide the names, but it says wealth management mobile application of something. As you can see, guys, here's Shazam, lifestyle, business. People are creating a lot of applications and they are putting in an APK format. It doesn't mean that somebody is doing a favor for you. And I'm going to show you something in the dynamic analysis. Cracking an application is extremely difficult. Trust me, it's really difficult. And even an super expert people, they spend at least a couple of days to crack an application. And can you guys tell me a good reason why should I spend my 2 or 3 days to provide you a free application? Yeah. So the only idea is I can provide you a free application. You can provide me a free Android device, okay? So here's the deal. If we agree on that, we can do that. So this is the thing that works. So now, if there is a cracked version of Office application, Windows or any kind of application, if I were in their shoes, if I don't embed a Trojan in that executable, I'm not going to create that because I'm not a charity organization. I'm a hacker. I don't have any ethic back. That's why, because I'm a hacker. And I'm not going to create a free application for just a donation to you guys because your intent is also bad. You wanted to use an application in an illegal way. And That's a good deal. So you're on my side. You are also a bad person just like me, and let's do some bad things together. You can use. So that's the idea. That's why, if you see an APK file that says a free version, trust me, it's a Trojan embedded version of that application. Is that too difficult to create a Trojan embedded version? No, not always. I mean, it depends. Some of the applications actually they're just downloading the legitimate version, embedding the Trojan, and sending it to the application store. It's exactly the same version. It's not ad free. It's just changing the text. It says ad free or unlimited, infinity blade application, so you can play forever. Okay, but it's not the case. So let's assume that we have an APK file. How can we analyze? So first of all, APK files are Java files, but it's a DAX formatted Java files. We need to come up with a jar file of this APK file. So there is a way to do that, okay? So here's the thing. In Android applications, when you write in Java code, Java is converted into DAX. Let's say not DAX first. It's converted into jar, Java library, and then it's converted into DAX formatted bytecode. Okay, this is something like an executable, and you can come back to the jar file if you use the proper tool. So we can come back to the jar, and of course we can come back to the Java file. It is also perfectly valid. So there is a way to come back to the source code of a APK file by using the proper tools. Let's see them in action. So this time I'm not going to use Windows because that requires Java runtime environment. It requires a lot of space. I have only Java runtime environment in my host machine, but you can easily create, set up the Java runtime environment and Java in your host system, and then decode the things. Let me see, where am I now? All right here. So the tool actually should be in the list. Okay, yeah, there we go. So this is the Dex to Jar open source project. It has Windows, Linux, and also Mac OS version of Dex code to the jar file. Okay, so if you download and extract that, you will get a folder something like this. Okay, it includes some license thing and also various version of this tool set. But the one that I'm really interested in is Dex to jar, and this is outdated. That's why you need to use D2J Dex to jar. Where is it? Okay, this is the latest version. We're going to use that. So the idea is simpler. So if I run this d2j-dex to jar.sh, it's just show me the help file and say that, hey guys, this is the working style. If you gave me some options and also some file and also the output, I'm going to do whatever you want to do. Okay, so all I need to do is I'm going to use the same code with this APK file. This is going to be my file 0. And then I'm going to put -o as an output. Of course, I can use some of the details here, but I don't need that. So the output is going to be the jar file. And I'm going to use, instead of .apk, I'm going to put jar. Okay? And hit enter. Cross fingers. There we go. We have the jar file of this particular applications. Okay? So how can we get the source code? There is an application which is also open source. It's just called jd-gui. Okay, this is the application that we're gonna use. JD.
Jar file is just a zip file.
Exactly, and kind of zip file. It's actually a container file. Here's my jd-gui, by the way. If you guys see jd-gui, please let me know, because the search is not working here.
Top right corner.
Top right? Okay, yeah, thank you. So this helps you to convert jar file to Java code, okay? So this is the second stage, and I'm gonna drag and drop my jar file to here. Okay, there we go. So first of all, it says com.metasploit.stage. You get the idea, right? It's something created with Metasploit, but we need to identify the command and control center and things like that. So this is the build configuration. How many people are Java developer? I mean, let's say Android developer. A few, okay. So you guys know that this is build configuration and that is the R class. They don't include any executable code. usually what you're looking for is either in main activity or in the payload. Okay, this is payload is actually imported in the main activity probably. So you can see that in here. Yeah, extends payload. Yeah, there it is. So main activity starts and it runs the payload and also start in path. So obviously I need to analyze this thing. So again, the same uh, ideology. So whenever an Android application starts, it runs the main activity first, always. Okay, main activity. Whenever you find the main activity, so you can focus on what kind of things are going to run on this thing. So apparently it's going to run the payload that starting path. So let's take a look at the payload class. Okay, it's right here. So when I look at it, I see a lot of things here. That's an interesting thing, by the way. So here's an AB string. It's all the numbers and letters. And also here I see IP address 172.16.16.144 and another port here, L host, L port, and also trails here and some URLs here. So that's interesting. First of all, it's going to use a support that is really uncommon. Secondly, L host, L port parameters are really familiar for us. Where is this coming from? Metasploit. It's Metasploit default settings are coming from this. So obviously this is something created with MSF Venom. Okay. So it's gonna connect to this IP address with this port and this URL. Probably the stager is a kind of HTTPS because it also have a URA section. And here we have a let's see, check some tests. It's not a problem. Random here. Okay, load stage. There we go. So load stage. For example, the stage. So let me give you a secret in malware world. So usually malware creators they wanted to hide their stager on their server unless you run the applications, okay? Because if they embed their stager in the executable, it can be easily identified with antiviruses. So they usually tend to hide their stager on the server side. Whenever this piece of canvas executable run on a PC, it's going to connect to the command and control center and it's going to download the stager. So it's going to do the bad habits after that. So for example, you can see any keylogger codes here. You can see any screen capturing or contact list and things like that. You can see anything here, but it says that I'm going to download payload.jar payload.dx. So it is going to download while it is running, and then it's going to run that. Okay, this is usually we see that. If you don't see anything, if you see something like this, that means that you need to contact with the command and control center. Of course, we're going to do that as well. We're going to contact with the command and control center for some files to see that what kind of things they are going to download and how can we treat them. Okay, and let me see. So it's an HTTPS connection, obviously here, and it's a GET connection, and it is going to. So here is the interesting thing. You see that the first X, 4X, what is that going to stand for? Because this is not a legitimate URL, right? It starts with 4X, and it's saying that substring of 4 start from the fourth string, and then continue with and trim all the white spaces. Okay, so finally you're going to get the actual IP address. This is the very simplest version of decoding, but malware creators they usually tend to hide their command and control centers in the static code analysis. And this kind of tricks that you can see, so you need to understand what kind of encoding is running here. So we identified that it's actually going to 172.16.16.144, and it's going to parse the integer with this only. Okay, so if you try to parse an integer like that format, it's going to parse only the numbers. And then it's going to be, of course, our local socket. It's going to connect and it's going to download the thing that it is planning to download. Okay, so that is how we can analyze the Android malwares as well. So this is the end of our static analysis. So do you guys have any question? What's that?
That IP address, it seems so incredibly naive. I mean, even if you're just examining the strings in the file, it's going to look like an IP address.
Yes. Yes.
So do people actually, I mean, why would we even bother?
So first of all, we bother with this because it says com.metasploit.stage. We have enough identity that this could be a malware. Secondly, this is an APK file we downloaded from a private market.
I mean, why would the author even bother doing that? You know, putting the X's in.
Ah, okay, okay. So here's the thing.
It's so easy to.
Yeah, but if he only, obviously this is a stupid example, but so if we put only the IP address in a plain text format, it can match with an IP address, and the IPS devices can easily block that IP address. If let's say I embedded a bad reputation IP address in my executable, your IPS device will probably block that, or your content filtering device will probably block that while we are downloading that. Okay, so those kind of things may affect. That's why they usually tend to encode their, encrypt their, IP addresses. So obviously, this is not a good example of encoding, but they usually try to hide their URL. So